This is my video for homework 1, question 5. The question is as follows. Suppose 100 people are waiting for a blood test for a kind of disease. The probability that for one person the test result is positive equals 0.1. Two test methods are as follows. Method 1 is that test each person one by one, then we have to do 100 tests. And method 2 is to divide 100 people into 10 groups with 10 people in each group, and then mix 10 people's blood and test that mixture. If the result is negative, then everyone in this group is negative. If the result is positive, then we test these 10 people's blood one by one. And now the number of tests becomes 1 plus 0 is 11. And the question is, on average, what is the number of tests we need to do by the second method? So, to start with, we need to, starting from here, analyze the method itself. So we see that we divide 100 people into 10 groups, and we test by group. We do the test by group because we start from mixing the 10 people's blood and test the mixture. So, if the result is negative, then everyone in this group is negative, and therefore the number of tests for a negative group, all negative, is 1. And if the result is positive, then we have to test all 10 people's blood because we don't know which one of them is positive. We have to find out. Therefore, the number of tests becomes 11, which is 1 plus 10. The number of tests becomes 11 in this case. So, for each group of the 10 groups, the number of tests is either 1 or 11. There's no exception. And we will continue by annotating the events. We annotate no positive in group K and only test once. That is only one test as event AK. Each person's result is independent because we are making this assumption by default because normally they are just random samples, and we don't have any information as to the disease itself, say how it is spread out or something like that, how everyone is infected. So we are assuming that each person's result is independent. They're independently getting sick or getting infected, and we don't know. But we don't know. We know that they are independent. That is better for calculation. And for each group K, the overall, the overall probability of it being fully innocent or fully uninfected is 1 minus 0.1, that is 0.9 to the power of 10. That is, every one of them is not infected because we know that where is it? For one person the test result is positive equals 0.1. The probability for one person to be positive equals 0.1. So the probability of all of them is negative, is about this much. So we have the expectation for number of tests for each group is 0.349 times 1 test for all negative, and 1 minus this number times 11 for at least one positive. That is 7.51 tests for each group. And so we can calculate the expectation for number of tests in total is 7.51 times 10. That is 75.1. And roughly 75 tests in the overall condition. So on the average, the number of tests we need to do by the second method is 75.